It was November 1942. The air above San Francisco Bay trembled with the clang of steel and the murmur of disbelief. Onlookers crowded the shoreline at Richmond, California, staring at something that shouldn't have existed. Before them, a complete Liberty ship, 441 feet long, 28,000 tons of steel and rivets turned to welds, was ready to slide into the water. Its name, SS Robert E. Peary. Its construction time, 4 days, 15 hours, and 29 minutes. Not months, not even weeks, just a handful of days. Officials, shipyard owners, and reporters had come expecting a publicity stunt or an unfinished shell. What they saw instead was a fully operational cargo vessel, ready to serve in the most demanding theater of war the world had ever known. The bay echoed with sirens and cheers, but beneath the noise lay something larger, the realization that the rules of industry had just been rewritten. This launch wasn't merely about one ship, it was about an idea taking physical form. In every rivet replaced by a weld, in every unskilled hand turned expert, a quiet revolution had begun. The crowd watched the Peary descend into the bay as if witnessing the impossible made mechanical. And yet, for the man behind it all, this moment was only the consequence of a bet made 2 years earlier, by someone who knew nothing about ships at all. In December 1940, Henry J. Kaiser, a construction magnate known for dams and highways, signed a contract that baffled Washington's maritime elite. He promised to deliver 30 cargo vessels for the British within 2 years. To many, it sounded like arrogance dressed as patriotism. Kaiser had never built a ship, never managed a shipyard, and barely knew port from starboard. Traditional builders scoffed. They had spent lifetimes perfecting their craft, working in yards whose traditions stretched back before the American Revolution. They viewed Kaiser as a well-meaning amateur, a man of concrete, not of steel and sea. Yet that ignorance turned out to be his greatest advantage. While the old shipwrights measured success in precision and patience, Kaiser measured it in speed and systems. When he toured existing shipyards in early 1941, what he saw struck him as medieval. Men riveting steel by hand, each step waiting for the last to finish, every process chained to tradition. His chief engineer, Clay Bedford, had recently returned from Detroit, where he'd watched Ford's assembly line stream endless rows of cars. To him, the contrast was absurd. If automobiles could roll off in sequence, why couldn't ships? The idea was simple, too simple for experts to take seriously. But Kaiser didn't want to impress experts. He wanted to outproduce an enemy. In the mudflats of Richmond, California, he built his answer. Instead of one grand line of ships rising from keel to deck, he created a sprawling industrial maze, 7 parallel building ways, surrounded by open areas for prefabrication. Sections of hulls, decks, and engine rooms were built separately and moved by rail to where they'd be assembled. The layout looked chaotic to the old masters. To them, it broke every rule of efficiency they'd been taught. But to Kaiser, it was an equation. Parallel work meant parallel progress. What once took months could now happen at once, like instruments in a symphony, each playing a different part of the same song. Then came the most radical break of all: no rivets. Riveting was the heartbeat of shipbuilding. Teams of skilled men heating, hammering, sealing. 1 million rivets for a single ship. Replace that with welding, and you weren't just changing a method, you were defying an entire culture. Welding was considered risky, unreliable at sea. The British banned it for hulls altogether. Yet with German submarines sending Allied ships to the bottom faster than they could be replaced, necessity had no patience for perfection. Kaiser knew welding from pipelines and dams, where miles of seams had held under far greater pressures than the oceans. So he welded ships together the same way he'd welded America's infrastructure. Admirals called it reckless. Kaiser called it progress. By mid-1941, sparks flew across Richmond as steel plates fused in hours instead of days. The first ship took 197 days, the second 169, the fifth 128, then 97, then 70. Each launch came sooner, smoother, cheaper. And the workers? They weren't shipwrights at all. They were former clerks, farmhands, mothers, teachers, people who had never stepped into a yard before. They came from across the country, drawn by ads promising training and a steady wage. Kaiser's genius wasn't just machinery, it was people. He broke every task into a repeatable rhythm. One crew welded seams, another built bulkheads, another assembled the deck. No one had to know everything, they just had to master their motion. Apprenticeship shrank from 4 years to 2 weeks. The result wasn't chaos, it was precision, born from simplicity. By the spring of 1942, Liberty ships were sliding into water faster than the Navy could commission them. The old yards, steeped in tradition, watched with disbelief as Kaiser's amateurs matched their speed, and then exceeded it. To them, this was more than competition, it was heresy. Yet the proof floated. His ships sailed, carried cargo, and came back. He had turned the art of shipbuilding into an act of mass production. Rivalries soon took hold across Kaiser's empire. His son, Edgar, oversaw Oregon's yards. Bedford ran Richmond, and both were fiercely driven. Newspapers tracked their builds like sports scores. 10 days, 9, 8. Each launch shattered the last record until Admiral Land himself demanded the contest stop, calling them stunts. But the spirit remained, a fever that no memo could cool. When Land visited Richmond that November and remarked offhandedly that Liberty ships still lagged behind other industries, Bedford took it personally. He promised the Admiral a ship in under 10 days. At 1 minute past midnight, November 8, 1942, the clock began. Over 1,000 workers rotated in relentless shifts. Prefabricated hull sections stood ready, engines pre-tested, deck houses pre-fitted. Cranes lifted pieces as if assembling a puzzle that already knew its shape. By day 4, the hull was complete. By hour 15, the propeller turned. When the Robert E. Peary hit the water on November 12th, it wasn't just a ship, it was a statement. That mastery could be taught, that tradition could yield to imagination, and that even the impossible could be timed with a stopwatch. Admiral Land, once skeptical, could only stand before the crowd and admit it. 6 months ago, I would have called this impossible. The cameras rolled, the workers cheered, and the old world quietly ended. From that day on, the Liberty ship was no longer just a vessel. It was proof that speed, organization, and human adaptability could redefine an entire industry. What began as one man's audacious experiment had become the heartbeat of Allied production. And the question now wasn't whether Henry Kaiser could build ships fast enough, but what else he might dare to build next. December 1940. The ink on the contract was barely dry when whispers began circulating through Washington and the maritime press. Henry J. Kaiser, the man of dams, highways, and concrete, had just promised to deliver 30 ocean-going cargo ships to the British government within 2 years. It sounded absurd. Kaiser's reputation was enormous in the field of landlocked miracles. He had carved roads through mountains, poured entire valleys into reservoirs, and turned the wild rivers of the American West into electricity. But ships? He had never built one, never managed a shipyard, never commanded a crew. To the established shipbuilding elite, it was as if a mason had volunteered to conduct an orchestra. The Todd Bath Iron Works in Maine, one of the oldest and most respected shipyards in the United States, reluctantly agreed to guide Kaiser through the process. Behind polite smiles, their engineers considered him a naive opportunist who had stumbled into a domain far beyond his depth. Their yards operated like temples of tradition, where knowledge passed from father to son, and every rivet carried the weight of centuries. To them, Kaiser's arrival from the world of concrete and earthworks was an intrusion, another businessman chasing wartime contracts in a field he couldn't possibly understand. But Kaiser's genius had never been in understanding what others already knew. It was in seeing what they refused to see. When he visited Todd's shipyards for the first time, he didn't look at the ships with admiration. He looked at the process with disbelief. Workers swarmed around the hulls like ants, each dependent on the step before him. Tools clanged, sparks flew, but everything moved in long, patient sequences. One finished before another could begin. It was craftsmanship, yes, but also inertia. Kaiser's instincts, honed on projects where speed meant survival, told him that this ancient rhythm would collapse under wartime demand. The world wasn't waiting for perfection. It needed production. That night, back in his hotel, Kaiser spread the shipyard blueprints across his desk. He wasn't searching for mistakes in the drawings. He was searching for a pattern of inefficiency. He traced his finger along the process lines and saw the same bottlenecks that had haunted construction sites before mechanization. Too much sequence, too little simultaneity. In his mind, the shipyard transformed. The long, narrow slipways became parallel tracks. The scaffolds turned into moving cranes. Each piece of the ship detached, prefabricated, waiting to be assembled like an enormous puzzle. In Portland, Maine, where winter winds whipped through the ironworks, the veteran shipwrights laughed at the outsider's sketches. "Ships aren't cars," one foreman muttered. But Kaiser wasn't comparing ships to cars. He was comparing systems to systems. Across the country, he had seen how Henry Ford's assembly lines in Detroit had changed the meaning of production. Every car that rolled off those lines was a testament to efficiency through division of labor. Kaiser wanted to build ships the same way. Separate the tasks, shorten the training, repeat the process until it became instinct. When he explained the idea to his chief engineer, Clay Bedford, the reaction wasn't laughter, but excitement. Bedford had just returned from Detroit himself, fascinated by the rhythm of factory movement, chassis gliding along tracks, parts joining in sync. To him, it wasn't madness to imagine ships assembled in sections. It was evolution. Together, they began sketching a new kind of yard, one built not around tradition, but around throughput. Instead of craftsmen, they'd have specialists. Instead of perfection, they'd have precision through repetition. The old guard dismissed the plan as fantasy, but Kaiser didn't need their permission. What he needed was a location, labor, and steel. The West Coast offered all three. There, in the mudflats north of Oakland, he saw the future taking shape, not in the form of blue water and shipwright hammers, but in the measured tempo of cranes, tracks, and welders. Every letter of protest from Washington only strengthened his resolve. Every condescending editorial that called him a damn builder playing sailor became fuel. He wasn't trying to join the shipbuilding establishment, he was trying to replace it. And as Europe burned and the Atlantic filled with smoke, the need for ships became not a debate, but an emergency. Kaiser's competitors believed he had overreached, that the war effort would expose him as a reckless amateur, but he was already thinking in numbers, not ships. Days saved, tons moved, workers trained. The blueprint he would follow wouldn't come from naval tradition. It would come from Detroit. And soon, the hum of an assembly line would echo not from a car factory, but from the edge of San Francisco Bay. By the time the first foundations were poured in Richmond, California, the idea of a shipyard had already been rewritten in Kaiser's mind. He didn't want the place to look like a port. He wanted it to look like a factory. Instead of narrow docks hemmed in by tradition, he envisioned open ground organized by geometry and motion. From the muddy flats beside San Francisco Bay rose a landscape that bewildered visiting engineers. 7 parallel building ways instead of 2 or 3, rail lines snaking between them like arteries, and colossal cranes spaced every 100 feet, capable of lifting entire hull sections at once. It looked nothing like the elegant, ordered shipyards of the East Coast. It looked industrial, mechanical, alive. Traditional builders shook their heads when they visited. John Riley from Bethlehem Steel wrote that the layout violated every principle of shipyard efficiency. To him, the prefabrication zones were far too large, the cranes absurdly powerful, the building ways too short for proper sequencing. Yet, even as he complained, he admitted something unsettling. The system made sense for what Kaiser was trying to do. It wasn't built for elegance, it was built for speed. Every element of Richmond's design followed that logic. Instead of assembling a ship piece by piece along a single track, Kaiser divided the process into dozens of synchronized operations. One crew worked on the bow in an open yard, another built the stern in parallel. The deck houses, cargo holds, and engine rooms were welded and fitted in separate zones, each functioning like its own miniature factory. Once complete, these enormous segments, some weighing over 100 tons, were lifted by cranes, carried along rail spines, and joined together at the building ways like puzzle pieces sliding into place. It was the Ford assembly line on a titanic scale, each motion measured not in minutes but in tons. In the old days, you couldn't install the engine until the hull was finished, or build the hull until the framing was set. Now, everything happened at once. While one team welded the keel, another prepared the engine miles away, ready to drop into position the moment the frame was sealed. The process turned what used to be linear into something symphonic, parallel sections converging in rhythm toward a single crescendo, launch day. The transformation wasn't just mechanical, it was psychological. Men and women who had never seen a ship before suddenly found themselves part of a living machine. Instead of a single master craftsman guiding apprentices, hundreds of workers repeated the same movement in coordination, their labor feeding into an invisible pattern that grew larger with every hour. There was no time for hierarchy, no time for reverence. The Richmond Yard demanded action, not heritage. Reporters who toured the site in 1941 described it as an industrial city growing faster than the ships it builds. At night, the lights from the welding torches made the sky flicker orange. Freight trains rattled through the grounds, carrying sections from one zone to another. Each new track, each crane, each worker was part of the same accelerating heartbeat. The rhythm of modern industry, learning how to fight a modern war. But for all the innovation in layout and movement, one obstacle still held the old world in place. The workers could move faster, the sections could roll like cars down an assembly line, but the joining method, the act of fusing steel to steel, remained trapped in the 19th century. Riveting crews hammered each connection by hand, heating pins to white-hot temperatures and sealing them with synchronized strikes. It was slow, exhausting, and bound to human endurance. If Kaiser wanted to make the clock truly bend, if he wanted Richmond to outpace the ocean itself, he would have to break the oldest rule in shipbuilding. He would have to stop riveting. When Kaiser's engineers first proposed abandoning rivets, the reaction bordered on outrage. To the old masters of shipbuilding, riveting wasn't just a technique. It was a language written in steel. For thousands of years, ships had been bound together by metal pins hammered through overlapping plates, every clang and echo of ancient craftsmanship. Rivets were tested, trusted, and visible. You could hear their strength ring through the hull. Welding, by contrast, was invisible, modern, and, worst of all, untested at this scale. Vice Admiral Emery Land of the United States Maritime Commission read Kaiser's proposal and nearly dismissed it outright. His private notes, later found in the archives, captured the tone of the establishment. Welding has never been proven reliable for hull construction at this magnitude. The British Navy forbids it entirely. Kaiser wants to bet America's supply lines on a theory. To most in the field, it sounded like gambling with national security. Insurance companies agreed, refusing at first to underwrite welded ships. The fear was simple. If one seam failed, the sea would do the rest. But fear had to compete with arithmetic. German submarines were destroying Allied shipping faster than shipyards could replace it. Every day, tonnage vanished beneath the Atlantic. Fuel, food, soldiers, lifelines. By the end of 1941, the Allies had lost over 3 million tons of shipping. At the current rate, Britain wouldn't just lose the war, it would starve before the next spring. Conventional shipyards took an average of 230 days to build a single cargo ship. At that pace, defeat was only a matter of scheduling. Desperation made innovators of everyone, and what had seemed reckless in peacetime began to sound like a risk worth taking. Kaiser had already proven welding's reliability in dam construction, where miles of steel seams held back walls of water far greater than any ocean pressure. He didn't see it as a gamble at all. To him, it was logic. Replace the slowest human process with the fastest mechanical one. A team of riveters could drive maybe 100 rivets a day. Welding could fuse those same plates in a fraction of the time, without the weight, without the noise, without the need for perfectly drilled holes. Every hour saved meant another ship closer to launch. The skeptics lined up anyway. They warned that welds would crack, that the steel would warp, that a single mistake could rip a ship apart mid-ocean. But Kaiser's mindset was blunt. He didn't need perfect ships, he needed enough ships. Perfection couldn't win a war of attrition. Quantity could. So, while traditional yards clung to their rivet guns, Richmond's sky bloomed with sparks. Electric arcs danced between steel plates, sealing them with liquid fire. The rhythm of hammers gave way to the hum of current. The pulse of industry turned electrical. Soon, the first welded Liberty ships began sliding into the bay. Inspectors ran their hands along the seams, looking for weakness. They found strength instead. Not beauty, never that, but functionality. The hulls didn't leak. The frames held. Welding not only cut the build time in half, but reduced the overall weight, allowing each ship to carry more cargo. What had begun as an experiment under duress was now rewriting the fundamentals of naval construction. Still, every success carried a question: how to multiply it. One shipyard could change its tools, but could it change its people? Kaiser's next challenge wasn't the steel, it was the hands that shaped it. To build on this scale, he would need to turn thousands of ordinary Americans into welders overnight, training them to master a process they had never even seen. The gamble had worked once. Now it had to scale into an army. The revolution that began with steel now moved into the human mind. Kaiser understood that machines alone wouldn't build faster ships. People would. The challenge was staggering. Where to find tens of thousands of skilled craftsmen when America's traditional shipyards had already drained the maritime labor pool? His answer was to stop looking for craftsmen altogether. Instead, he looked for anyone willing to learn. Across the country, newspapers carried ads offering high wages, steady work, and training for patriotic builders. Men and women who had never seen the ocean arrived by train, suitcase in hand, ready to join the war effort. Secretaries, waiters, farmhands, teachers, housewives, all stepped into Richmond's gates and into a new kind of classroom. The air smelled of ozone and hot metal. Sparks flashed like fireflies over the mud. They were given masks, gloves, and 2 weeks. That was all Kaiser needed. Traditional shipwrights sneered. They had spent 4 years apprenticing just to weld a single joint on a warship hull. To them, the idea that a farmer could learn to weld in days was an insult to the craft. But Kaiser's philosophy was ruthless and elegant. Don't train workers to do everything. Train them to do one thing perfectly, then repeat it endlessly. The complexity of shipbuilding was shattered into thousands of small, repeatable tasks. One team learned only to weld vertical seams on bulkheads. Another specialized in horizontal joints on deck plates. A third installed identical sections of framing again and again. Within 2 weeks, what had once been an art became an instinct. The effect was immediate. In January 1942, Richmond's first Liberty ship required 197 days to complete. By May, it took 128. By autumn, 70. The workforce wasn't just building faster, they were learning faster. Every ship completed became a lesson that shortened the next. Learning curves collapsed under the weight of repetition. It was the industrial version of muscle memory, scaled to thousands of people moving as one. Inside the yard, the rhythm of production took on the tempo of music. Trains clattered over rails, cranes groaned overhead, welders' torches hissed in overlapping choruses. Day and night, the shipyard pulsed with life. Kaiser had created not a workplace, but a living organism, self-learning, self-correcting, endlessly accelerating. The workers began to feel it too. Pride replaced hesitation. They timed their welds, competed across shifts, bragged about which team could finish a section faster. Posters went up, tracking completion times, and names of record-breaking crews appeared in the local papers. It wasn't propaganda, it was motivation. When a ship launched ahead of schedule, the entire yard cheered. What began as a desperate experiment had become a movement, and with every launch, something more than steel was forged. The people themselves began to change. Women who had never held tools before became supervisors. Migrants from the South, once denied skilled jobs, now led teams of welders. In a nation still divided by gender and race, Richmond was quietly rewriting the rules. The war demanded hands, and the assembly line didn't care whose they were. By the end of that summer, Kaiser's untrained army was outperforming every traditional shipyard on the coast. Each day shaved minutes, then hours, then entire days off the clock. It wasn't luck, it was design. When you made production a rhythm, people learned to dance to it, and soon that rhythm would turn competitive. The drive for speed was no longer just necessity. It was pride, a sport where the scoreboard was made of steel and time itself was the opponent. By late 1942, speed had become a kind of fever. What began as necessity had turned into a contest, and every Kaiser yard wanted to prove it could outbuild the others. The challenge started quietly, friendly boasts traded between foremen in Richmond, Vancouver, and Portland. But it didn't stay friendly for long. Newspapers picked up the rivalry, printing ship completion times as if they were boxing scores. Crews bet dinner money on whose yard would break the next record. The competition electrified the workforce and terrified the admirals, who saw the country's most vital production lines turning into a racetrack. In September, the Oregon Shipbuilding Corporation stunned everyone by completing the Joseph N. Teal in just 10 days. 10 days from laying the keel to sliding into the Willamette River, a pace so fast that even the skeptics stopped laughing. The achievement turned shipbuilding into a public spectacle. Headlines called it the Miracle of Portland. For Kaiser's engineers, it was a spark of pride. For Clay Bedford, running the Richmond yards, it was a challenge he couldn't ignore. So when Vice Admiral Land toured Richmond that November, admiring the progress but remarking offhandedly that even 10 days couldn't rival true mass production, Bedford took the comment like a gauntlet thrown. He promised to build one faster, under 10 days, without halting normal production, without cutting corners, without excuses. Land agreed, partly in disbelief, partly in curiosity. And so, the countdown began. At 1 minute past midnight, November 8th, 1942, more than 1,000 workers began what would become the most famous sprint in industrial history. Prefabricated sections already lined the rails like waiting chess pieces. Bows, sterns, deck houses, cargo holds, all pre-welded, pre-tested, and staged for lift. Cranes swung like metronomes, lowering sections with mechanical precision. Teams rotated in 12-hour shifts, sleeping on site, eating at their stations. The Richmond yard moved like an organism that never blinked. On the 4th day, the hull was whole. By the 5th, the engine was installed and tested. By the end of the 6th, the propeller spun in the bay's wind. And at 3:30 p.m. on November 12th, the SS Robert E. Peary, 441 feet of American steel, slid down the launching rails, hitting the water just 4 days, 15 hours, and 29 minutes after work had begun. Even the skeptics who came expecting failure found none to point at. The ship floated, complete, balanced, beautiful in its brute simplicity. Admiral Land, who had once questioned whether welding belonged on a ship at all, stepped to the microphone and said what everyone was thinking. 6 months ago, I would have called this impossible. Henry Kaiser has made traditional wisdom obsolete. Reporters scribbled every word. Cameras clicked. The moment marked not just a new record, but a new reality. The old rules of shipbuilding had been erased. What followed was even more astonishing. The Peary wasn't a fragile stunt. Its construction wasn't rushed into failure. Once fitted out and commissioned, it performed as any other Liberty ship would, delivering cargo, crossing oceans, serving the war effort without incident. The test that was meant to expose the limits of mass production instead exposed its power. Traditional builders had argued that speed and quality were opposites. The Peary proved they could coexist if the process was built right. Kaiser's system didn't depend on flawless craftsmanship. It depended on repeatable precision. The ships weren't perfect, but they didn't need to be. They were adequate, and adequate was exactly what victory required. Every ship that followed carried that lesson forward. As Richmond's output surged, costs dropped, and schedules tightened, the skeptics' arguments evaporated. Each Liberty ship cost less than the last. Each one completed faster, each one strong enough to weather the Atlantic. Welding defects appeared, yes, but they were studied, solved, and eliminated. The data became doctrine. The phrase good enough turned from an insult into a strategy. By the spring of 1943, Kaiser's yards were launching ships in 40 days on average, more than 5 times faster than the industry standard. Loss rates stayed low, comparable to pre-war vessels. Liberty ships that critics once called Kaiser's coffins were now the backbone of Allied logistics, carrying everything from fuel to tanks across oceans ruled by submarines. It turned out that perfection, that sacred obsession of the old shipwrights, was the enemy of victory. Adequate multiplied by thousands could do what perfection multiplied by dozens never could: win a war. And with every new hull sliding into the bay, the question grew louder. echoing from steel to strategy. If good enough could change the course of battle, what might happen when that idea was applied to everything else? By the middle of 1943, Richmond's cranes no longer startled anyone. They were simply part of the landscape, always moving, always lifting. What had once been unthinkable had become routine. The average Liberty ship now took 42 days from keel to launch. 3 new ships a day left American yards, their gray hulls gliding into the water faster than German U-boats could sink them. The mathematics of survival had shifted. Every submarine kill now carried less weight, because by the time a Liberty ship vanished beneath the Atlantic, 2 more were already on their way to replace it. In the offices of the Maritime Commission, the charts told a story as decisive as any battle map. The Allies were no longer losing the war of tonnage. They were producing their way to victory. Admiral Chester Nimitz would later write that the Pacific War was won not just by soldiers and sailors, but by the factories that fed them. And none symbolized that transformation more than Kaiser's empire of shipyards along the West Coast. The numbers were staggering: hundreds of hulls, thousands of voyages, millions of tons of cargo. But beneath the statistics lay something more profound: the people who made it possible. At the height of production, Kaiser's 7 yards employed nearly 200,000 workers. Of these, over 40,000 were women, many of whom had never worked outside their homes before. They learned to weld, to rivet in smaller projects, to operate cranes that swung steel sections heavier than entire locomotives. Their gloves were too large, their masks awkward, but their precision was remarkable. The posters calling them Rosie the Riveter weren't exaggerations. They were portraits of a real revolution. Standing beside them were tens of thousands of African American workers who had come west from the segregated South, drawn by the promise of fair wages and real skill. In Richmond, Kaiser didn't care about ancestry or pedigree. He cared about output. Skilled positions that had been closed to minorities for generations were suddenly open. Welders, fitters, foremen, roles that carried authority and pride, were filled by men and women whose opportunities had once ended at a factory gate. The assembly line became the great equalizer. This shift shattered the guild system that had defined American industry for centuries. In the old yards, skill was inherited like property. Fathers taught sons, masters trained apprentices, and entry came only through lineage. Kaiser replaced that hierarchy with a stopwatch and a training course. It didn't matter where you came from. If you could meet the standard, you belonged. The results spoke louder than any policy speech. The ships kept coming. The pace kept rising. The war machine had found its rhythm, and it pulsed with the heartbeat of ordinary people doing extraordinary work. Reporters visiting Richmond during those peak months called it the factory that won the ocean. At night, the horizon glowed orange from welding arcs and floodlights. The roar of steel, the hiss of steam, the rhythmic clang of cranes, it sounded less like labor and more like music. Even the skeptics from old shipyards who had once mocked Kaiser's amateurs began sending engineers west to learn from him. The apprentices became teachers, the outsiders became the model. Every launch carried the same quiet message. The future no longer belonged to those who guarded tradition. It belonged to those who could adapt. Kaiser hadn't just changed how ships were built. He had changed who was allowed to build them. In doing so, he redefined the boundaries of industrial possibility. And as the tide of war turned in favor of the Allies, the effect of that change began to move beyond the bay, beyond the shipyards, beyond even the war itself. The revolution in Richmond was no longer confined to steel and water. The ripple was escaping the fence, spreading into every corner of American life where innovation met necessity, and where the impossible had quietly become routine. When the guns finally went silent and Liberty ships no longer launched to the sound of sirens, many believed the great experiment would vanish with the war. Shipyards that had once roared around the clock grew quiet. Workers returned home, cranes stood still, and the yards that had employed entire cities seemed destined for rust. Yet the true legacy of Richmond was not its silence. It was what that silence concealed. The methods born in wartime urgency refused to die. Prefabrication, modular construction, and parallel assembly had proven themselves too efficient, too adaptable, too powerful to remain confined to one moment in history. Kaiser saw this before anyone else. He understood that his shipyards were not just a wartime miracle, they were a prototype for how America could build everything. During the war, he had built his own steel supply at Fontana, California, constructing an enormous mill 5 months ahead of schedule to feed his yards. That mill would become the foundation of California's post-war industrial boom, establishing the West Coast as a steel-producing power for the first time. From there, the logic of integration, control the materials, train the labor, systematize the process, spread to everything Kaiser touched. When the ship contracts ended, he didn't dissolve his empire, he redirected it. His organization turned to peacetime challenges with the same relentless practicality it had applied to war. The same principles that once assembled ships now built homes, bridges, and highways. The modular housing movement of the late 1940s borrowed directly from Richmond's blueprints, standard sections fabricated off-site, then assembled in days instead of months. Factories that had once produced bulkheads now stamped out walls, beams, and trusses. The post-war suburbs of America, the quiet streets, the endless repetition of houses, were, in a way, another form of Liberty ship. Even healthcare carried the imprint of that transformation. To keep his workers healthy during the war, Kaiser had partnered with physician Sidney Garfield to create a prepaid medical plan for shipyard employees. It offered on-site clinics, affordable care, and preventive medicine, ideas considered radical in the 1940s. After the war, that system evolved into Kaiser Permanente, one of the largest healthcare networks in the United States. What began as a wartime necessity became a model for modern managed care. The philosophy was the same: organize people, eliminate waste, build systems that scale. Meanwhile, across the Pacific, countries rebuilding from ruin took notice. Japan, whose shipyards had been reduced to rubble, studied the Liberty ship program in detail. Engineers from Nagasaki and Kobe dissected its methods: prefabrication, sectional welding, parallel assembly, and rebuilt their maritime industries upon them. A generation later, South Korea followed suit. The massive shipyards of Ulsan and Gyeonggi that would dominate global shipping in the second half of the century were direct descendants of Kaiser's wartime designs. The techniques born in a California mudflat became global doctrine. Industrial historians often speak of technological revolutions as the product of genius inventions: the steam engine, electricity, the microchip. Kaiser's revolution was different. He didn't invent a new machine. He invented a new way of thinking about machines, people, and time. He proved that scale could be planned, that complexity could be modular, and that expertise could be trained. The ideas that welded Liberty ships together now welded the modern world into place. By the 1950s, even the skeptics had forgotten they were once skeptical. Prefabrication was no longer an experiment. It was standard practice. Welding replaced riveting everywhere. Factories, hospitals, housing projects, even bridge construction adopted Kaiser's rhythm of parallel production. The entire industrial vocabulary of the mid-century world carried echoes of Richmond: prefabricate, standardize, assemble, repeat. The Liberty ship program was never just about ships. It was about proof that systems could outthink tradition, that people could be taught to exceed expectations, and that the future belonged not to the patient craftsman, but to the organized builder. And so, the question lingered long after the war ended and the last Liberty ship was scrapped. What was Kaiser's true legacy? The steel that carried across oceans, or the mindset that redefined how humanity builds its world? By the time the last Liberty ship slipped into the water in 1945, the war had been decided not only by soldiers and sailors, but by a principle, one that could be measured in hours saved, welds made, and minds changed. The SS Robert E. Peary may have been the headline, but its real significance was not in how quickly it was built. It was in what that speed revealed about human potential when freed from the drag of tradition. In less than 4 years, Henry Kaiser's shipyards and their imitators had produced 2,810 Liberty ships. Each one carried more than cargo. It carried proof that the limits people defend most fiercely are often the ones they imagine. The numbers told the story better than any speech. A process that once required 230 days could now be done in 42. Labor hours fell by more than half, even as wages rose. Welding, once dismissed as reckless, became the global standard. Rivets were history. Apprenticeships that took years had been replaced by training programs that took weeks. The arithmetic of progress was brutal in its simplicity. Organize for speed, specialize for precision, and challenge every assumption about the way it's done. When you did that, what once seemed miraculous became routine. Of the 2,710 Liberty ships built, only a fraction were lost in action, fewer than 8%. Some suffered brittle fractures or weld cracks, but each failure became data. Each lesson folded back into design. The process learned from itself, evolving in real time. Perfection was no longer the goal, progress was. And progress meant adaptation, iteration, motion without pause. When the war ended, those ships scattered across the globe, hauling coal, grain, and memory. Many were scrapped, some sold, others refitted for civilian life. But even as their steel was melted down, their legacy refused to cool. A few survived as monuments, the John W. Brown in Baltimore, the Jeremiah O'Brien in San Francisco, the Hellas Liberty in Greece, floating museums that still hum with the rhythm of a revolution. Others simply lived on through influence. Every container ship, every oil tanker, every modern assembly line owes something to their lineage. The lesson that outlived the Liberty was not about ships at all. It was about systems, about daring to see a process not as a chain of inherited rituals, but as a problem that could be solved. Kaiser's genius was not invention, but inversion. He turned the equation of mastery upside down, proving that skill could be divided, distributed, taught, that people, when given purpose and structure, could achieve the impossible, not through brilliance, but through coordination. In his own words, "We don't build ships, we build shipyards, and the shipyards build the ships." It was more than a slogan. It was a manifesto for an age of systems, a recognition that progress is not the work of the gifted few, but the organized many. The Liberty Ship program didn't just change how things were made, it changed how people thought about making them. Even today, its fingerprints remain. In the robotics plants of Japan, the modular construction yards of Korea, the aerospace lines of Seattle, and the prefabricated housing factories of Europe, the same logic hums beneath the surface. Simplify, specialize, synchronize, iterate. The sparks that once flew over the Richmond mudflats still burn, translated into automation and algorithms, but guided by the same principle, efficiency born from imagination. The Liberty ships themselves are mostly gone, their names fading from holes now buried under waves or rusting in forgotten harbors. But the revolution they embodied never sank. It lives in every modern factory that still builds the Kaiser way, where each process begins with a question. What if impossible is only tradition talking? And it ends, as it did in 1942, with a simple, enduring truth, that human ingenuity, when organized and unleashed, can move faster than anyone dares to believe.